I myself, Neha Athavale, will present on the topic of two-port networks based on the subject electrical network theory. Contents: network functions, two-port networks, driving and transfer function, network equations, Z, Y, ABCD, H parameters, condition for symmetry, reciprocity, interconversion and interconnection of parameters. Network functions: consider the network consisting of only passive elements. Any network can be schematically represented as a rectangular box. If the conducting wire is connected to any one of the nodes of the network and brought out of the box, it is called as a terminal. If there is only one pair of terminals, it is one-port network. If there are two terminals, it is two-port network. The port to which energy source is connected is called as driving point or the network or input port, and the port to which is connected to the load is called as output port. Now this is two-port networks. This is a standard configuration of a two-port networks. You can see I1 and I2 are the currents which is entering inside the networks. When you supply V1 and V2 as the voltages at port 1 and port 2, currents I1 and I2 flow inside the network. This is by convention. So current must enter inside the network. Driving point function: if the excitation and response are measured at the same pair of terminals, the network function is known as driving point function. For only one port, only one voltage and current are specified, and hence only one network function and its reciprocal can be defined. The driving point impedance function is Z of S equal to V of S upon I of S, and its reciprocal driving point admittance function is Y of S is equal to I of S upon V of S. Thus we can define Z of S and Y of S as driving point function. Driving point function: Z11 is V1 upon I1, Y11 is I1 upon V1, Z22 is V2 upon I2, Y22 is I2 upon V2, everything in frequency domain. So, in S domain. Transfer function: it is used to describe the networks which have at least two ports. It relates to voltage or current at one port to voltage or current at another port. These functions are also defined as a ratio of response transform to an excitation transform. G21 is V2 by V1, alpha 21 is I2 by I1, Z21 is V2 by I1, Y21 is I2 by V1. G21 is voltage gain, alpha 21 is current gain, Z21 is impedance, Y21 is admittance. Everything in frequency domain. Now these are the some of the two-port networks parameters. Z parameters: V1, V2 in terms of I1, I2. Y parameters: I1, I2 in terms of V1, V2. ABCD parameters: V1, I1 in terms of V2 minus I2. Hybrid parameters: V1, I2 in terms of I1, V2. And for transmission parameters, current I2 is considered negative because it is opposite to the current conventions which is followed. Now this is a definition of Z parameters. In this, if you see, either current I2 is 0 or current I1 is 0, hence it is called as open circuit. Since it is a ratio of V by I, it is called as impedance parameters, hence the name open circuit impedance parameters. It may be at the input or output or both the ports. Now Y parameters, here if you see, it is a ratio of I by V, so it is admittance parameters. Either V1 or V2 is 0, so it is short circuit parameters, hence the name short circuit admittance parameters. This is also at the input and output side or at both the ports. So these are Y parameters. This is a summary of Z and Y parameters which is represented in matrix form. V1, V2 in terms of I1, I2 or I1, I2 in terms of V1, V2. Now this is nothing but the transmission parameters: V1, I1 in terms of V2 minus I2. Transmission engineers consider the current I2 flowing outside the network, but by convention I2 must flow inside the network. So I2 is considered negative. So this is a definition of ABCD parameters. In this, either I2 is 0 or V2 is 0. Now this is hybrid parameters, in which we have V1, I2 in terms of I1, V2. This is nothing but the hybridization of both the ports, in which we consider V1, I2 in terms of I1, V2. Now this is nothing but the equivalent circuit of hybrid parameters, where we can apply KVL or KCL as per required. Condition for symmetry and reciprocity for Z, Y, ABCD and H parameters. First, let's see the definition. A network is said to be reciprocal if the ratio of transform of excitation at one port to transform of response at another port is same if the excitation and response are interchanged. This is condition for reciprocity for Z, Y, ABCD and H parameters. Condition for symmetry. For the network to be symmetrical, voltage to current ratio at one port is same as voltage to current ratio at another port with one of the port open circuited. And these are the conditions for symmetry. Now this is interconversion of parameters, where we can convert one parameter to another parameter. We can express one parameter in terms of another parameters. This is the table which shows Z expressed in terms of another, Y in terms of another, ABCD in terms of another parameters, and H in terms of another parameters. Now while seeing the table, if we see Z in terms of ABCD, similarly with other parameters. For Y, ABCD or H. In this table you can see, suppose we write Z11 is delta H upon H21. That means Z parameters are expressed in terms of H parameters. Similarly, suppose we take ABCD, A is equal to Z11 by Z21, then ABCD are expressed in terms of Z parameters. Similarly with the other parameters, we can express one parameters in terms of another parameters. That means we can convert one parameter to another parameters. Now this is the way in which we can connect the two-port networks, parallel connection, series, cascade. In parallel connection, we have the summation of Y parameters as total Y parameters, series summation of Z as total Z, and in cascade, multiplication of individual ABCD as a total ABCD. Similarly, we can do series parallel for Y parameters. Thank you.